We use a lot of systems. We use handheld cameras outside an airplane, aerial photographs from higher up, but our real payoff comes with satellite data, and I'll get to that in just a second. There's early remote sensing. The Germans did this at the turn of the last century. Pigeon, camera system, and notice right here, the wings of the pigeon. They really are. Now, I've had high school kids, the picture's a little blurry, say, well, what's that? Well, it's a trigger mechanism for the wings, but I told the kids it's extra roll of film in case the... What scares me is some kids say, oh yeah, okay, I'll write that down. That's remote sensing. We can see the Black Forest and an intersection in downtown Berlin in 1890. And there's part of the Black Forest and a castle. We've got a permanent record of what that area looked like at a given time. Now, more recently, aerial photography, downtown in the mall. I didn't get it processed in time, but our satellite flew over on January 20th at 10 o'clock in the morning, and it was cloud-free. I had hoped to have that here today, but I didn't get it in time before I got on the plane yesterday. Military, you know this. Military's been flying satellites for 40 years. And they've started to declassify some of that photography. And we have it at Sioux Falls, and we make it available. Lake Chad in Africa, one of the larger lakes in the African continent, as it dries. Every 40 years it goes almost dry, and then it fills up again, then goes dry. And there are studies analyzing why that is going on and what the repercussions are of it. Color aerial photography of the New Orleans area, and here's our main bird, the Landsat. We're observing conditions on the land mass of the planet. And you're going to hear more about Landsat than you probably want to.
Satellites different than the CIA? Or
yeah. Yeah.
Now, are your satellites ones that Google uses when Google says you can pull up their address and they can show you a picture?
They use our aerial photography. I'm sorry, I'm supposed to repeat the questions. Gail, I forgot. Does Google use our stuff, and are we different from the CIA and the military satellites? Military satellites, I don't know a great deal about them. They have a whole series of spacecraft up there. Most of those are in what they call a geosynchronous satellite. As the planet turns, they're hovering right over the same spot all the time. They're looking at key areas around the world. They don't want whole world coverage. They're looking at targeted areas. That means their satellite has to be way out in space, approximately 23,000 miles out, looking down, so it moves at the same speed as the planet rotating. Ours is different. I wish I had a basketball with me this morning. Imagine this is a basketball, and you had a ribbon, and you had to wrap up that basketball. You'd bring the ribbon down around, and then around to another part, and around, and around, and around. Eventually, you'd get the whole basketball covered. Polar orbiting is what we call that. That's what we do. That way we get the whole world, not just that one spot. And we can fly closer to the surface of the planet then. Okay? Now, I'm sorry if that, I don't mean to give a physics lecture, but that's a basic principle. Now, Google, yeah, they have access to our stuff just as anybody else does, at no charge. Gail, what do you think? No, we can't. I'm sorry. It's a little blurry, but all right. Why satellites? Full global coverage. Now, sure, the satellite flies over the oceans, 2/3 of the land or surface of the planet, but our data are not useful for ocean studies. We don't get the level of detail that would be necessary to check, you know, reef buildup and that sort of thing. Repeat coverage, theoretically, every 8 days with 2 satellites up there. We've got 2 operating right now. We can look at very large areas. Each satellite image covers an area about 115 miles on a side in one shot. Well, actually, that's a little deceptive. It's always collecting data, but we cut it off into 115-mile segments. And We don't look at it just as a camera does. We use sensors that detect the amount of reflected light back up at the bird. And we can cut off those bands of light energy to highlight certain features. And I'll show you examples of that here shortly. And our main bird is the Landsat satellite. Been operating since '72. We've got most of the landmass covered. Why wouldn't you have all of it? Well, there are a couple of areas right up around the polar caps because of the way the orbit is built that we don't get. The near polar caps. We get everything else. The next problem is we can't penetrate cloud cover. So Central America is often cloud covered. It takes a long time to get cloud-free coverage. Measuring the solar reflectance, the smallest features we can identify is about the size of a baseball field. We don't care how many cars are in a parking lot. And the reason we don't care about that is we're looking at a broader view. And secondly, if you double the level of detail, you quadruple the computer processing time needed to process the signal. And so it's a trade-off. The military and the commercial sector have satellites that get down to about 1 meter. That's the sharpest I've seen. You know, you see on all these spy movies, how to say this, in Patriot games where Harrison Ford, where they start with one of our satellite images, and I was all excited when I said, oh, they're using our image, and they kept enhancing it, enhancing it, enhancing it, and they got down there, and they could look right down and tell that one of the terrorists was female because of her cleavage. Well, she'd have to be at least 30 meters large. We're always fighting that battle with the media.
Why is Central America always clouds? Made that statement.
Well, you're at the junction between the Atlantic and Pacific, and so the humidity and the wind currents are the major factor there. And temperature. You've got that perfect balance of temperature, humidity, and wind currents. You have places in Malaysia that are the same. And also the amount of humidity and chemicals coming up from the forest areas. Okay. I said we're in a near polar orbit. The bird comes down. Takes about 99 minutes to make a complete orbit around the Earth. Takes 16 days to cover the entire planet. Think again of that basketball and those bands of ribbon. It'll take quite a few bands, about 200 of them, to completely cover the planet. We have two birds operating, 5 and 7. 5 was launched in 1984. It had a design life of 5 years. March 1, it ends 25 years of coverage. It's a remarkable engineering accomplishment. 7 went up on April 15, 1999. Again, a design life of 5 years, and it's still operating reasonably well. So we're on borrowed time.
Do you go up and do you have to repair these things or no?
5 was designed to be repaired by the shuttle, and so we put extra fuel on board it. It's too high for normal operations, and it turns out the shuttle couldn't go that high. So once it's up there, we can't fix it. So it's too high up. But the bonus was, with that extra fuel, we could extend the life of 5. Because every so often you have to adjust the satellite. Gravity and other factors solar winds will move it around a bit, and you have to bring it back in track. And that takes fuel up there. Well, the fuel that we put on so that we could bring it down for shuttle repairs, theoretically, has actually kept it going longer than we expected. It's been a remarkable bonus. And you can see what I explained earlier. Our antenna can capture anything immediately within range of Sioux Falls. And we're right here.